Hello friends, in this video let us discuss previous year electronic science paper which was conducted by UGCNET in the year Jan 2017. In this video I am going to discuss question number 1 to question number 25. Moving on to question number 1, what they are given is the ionized concentration for donors is given by. We know that we will be having a conduction band over here and we will be having a valence band over here. At absolute 0 Kelvin, your intrinsic level will be exactly in between conduction band and valence band. Your Fermi level will be in between conduction band and valence band. As temperature increases, or if you are increasing the doping concentration, your Fermi level will be making a shift. Nothing but in the case of N-type, your Fermi level will be lying close to conduction band, and in the case of P-type, your Fermi level will be coming close to valence band. In the case of tunnel diode, what you are going to do is you are going to dope degeneratively, nothing but you are going to dope extensively, nothing but you are going to dope more. So at that time your Fermi level will be crossing the conduction band, your Fermi level will be crossing the valence band also. So this is the structure of, or this is the variation of Fermi level. So the ionized concentration for donors is given by Nd divided by 1 plus exponent of Ef minus Ed divided by Kt, where K is the Boltzmann constant and T is the absolute temperature. You are going to express the temperature in Kelvin, nothing but it is T plus 273 degree centigrade. So T should be in Kelvin and K is the Boltzmann constant, Ef is the Fermi level. So the corresponding option that is going to follow is option 3 is correct. Moving on to second question, the Y parameters of the network is as shown in the figure. You have to write the matrix. So for the given circuit, you have to write the Y parameter. Now, in the case of Y parameter, we know that I1 and I2, the currents I1 and I2 are functions of V1 and V2. So how can I express I1 and I2? I1 equals to Y11 V1 plus Y12 V2. Similarly, how can I express I2? I2 is given by Y21 V1 plus Y22 V2. Now, in order to calculate Y11, what I am going to do is I am going to make V2 as 0. Y1 equals to I1 divided by V1 at V2 equals to 0. What is current divided by voltage? It is 1 divided by resistance, that is R1. So I got Y11 equals to 1 divided by R1. So I can eliminate option 2. What is Y12? So Y12 is given by I1 divided by V2 at V1 equals to 0. At V1 equals to 0. So what is the current that is I1 when V1 equals to 0? When voltage is not there, current will also not be there. So I will be getting Y12 equals to 0. Such that I can eliminate option 1 also. What is Y21? Y21 is given by I2 divided by V1 at V2 equals to 0. Whenever V2 is 0, what is the current that is flowing in this path? In the open branch or in the open path, current I2 equals to 0. Now, I need to calculate what is Y22. Y22 is given by I2 divided by V2. I2 divided by V2 at V1 equals to 0. I2 itself is 0. So Y22 also will be 0. So the corresponding option that is going to follow is option 3 is correct. Moving on to third question, what they are given is, in the circuit that is shown in the figure below, you have to calculate the base current IB. So let me take this current as IB, and this current I am going to take it as the collector current, that is IC. And the voltage drop across base to emitter, I am going to call it as VBE. I am going to call it as VBE. Now, what is this base current IB? So in order to calculate the base current IB, what I am going to do is I am going to apply KVL across the outer loop. So what I will be getting is VCC minus IB times of RB minus VBE, which is equals to 0. In the case of KVL, if I am moving from plus to minus, I am going to take it as minus. If I am going from minus to plus, then it is a rise. I am going to take it as plus. So this is my convention. So you can take minus to plus as minus, plus to minus as you can take it as plus also. Now what is the value of VCC? It is 12 minus what is the value of VBE? It is 0.7, which is equals to IB times of RB. Now what is 12 minus 0.7, which is 11.3, divided by the current, the resistor value, that is RB, which is equals to IB. Now look at the values of current. Current is in the order of microamperes. So a resistor should be in the order of mega ohms. But they have given 1 milliohm. Actually it should be 1 mega ohm. So I'll be getting IB, which is equals to 11.3 divided by 1 mega, such that I'll be getting the current, which is equals to 11.3 microamperes. So option 2 is going to follow. So this is how you are going to find. Moving on to fourth question, the output of the circuit is given by. The output of a NOT gate, when input is A, means you will be getting A bar. Similarly, here you will be getting A plus B the whole bar. So here you will be getting B bar. Here what you will be getting? B plus C the whole bar. Now the output of an OR gate will be A bar plus A plus B the whole bar. So how can I write A bar plus what is A plus B the whole bar with the help of De Morgan's law? It is A bar into B bar, which is equals to, if I am taking A bar as common, I will be getting 1 plus B bar, which is equals to A bar, because we know that 1 plus B bar equals to 1. Similarly over here it is B bar plus B plus C the whole bar, which is equals to B bar plus B bar into C bar, which is equals to, let me take B bar as common, I'll be getting B bar into 1 plus C bar, which is equals to B bar. Able to follow? Now what is the output over here? The inputs are A bar and B bar. So you'll be getting A bar into B bar the whole bar. Now with the help of De Morgan's law, if I'm calling this A bar as X and if I'm calling this B bar as Y, then it is X into Y the whole bar. So what is X into Y the whole bar? It is X bar plus Y bar. So I'll be getting A double bar plus B double bar, which is equals to A plus B, which is equals to A plus B. Hence the suitable option that is going to follow is option C is correct. Moving on to fifth question, what they are given is, for a Q to be in idle state in the case of 8086, so we have to tell when this Q will be an idle state. So in the case of microprocessor 8086, you will be having a 6-byte queue. You will be having a 6-byte queue. Nothing but next sort of instructions which has to be executed will be stored in a queue. So priorly the instructions are fetched and it will be stored in a queue. So the program counter, what it is going to do is, it is going to fetch the instruction one after the other, such that the execution rate will be very much faster, because you will be having a 6 instructions that is readily available. What this execution unit will be doing is, it is going to execute nothing but it is going to fetch the instruction, decode and execute. Thereby speed of execution will be very much faster. Now as I told, it is going to support 6-byte queue. You will be having a condition based on QS1 and QS0. When QS1 and QS0 equals to 0, 0, then it is no operation. Then it is no operation. When it is 0, 1, so what it will going to do is, first byte of Q or first byte of first opcode will be fetched from Q. Will be fetched from Q. Able to follow? When it is 1, 0. When it is 1, 0, nothing but you are going to flush the queue. Nothing but you are going to empty the queue. When it is 1, 1. When it is 1, 1 means subsequent fetching is going to take place. Nothing but one instruction after another instruction. Nothing but subsequent fetch. Now when the contents of the queue will be flushed, whenever you are going to execute or whenever you are going to encounter jump or call instructions or interrupt service routine, or whenever you want to provide a service to the interrupt, at that time the contents of the queue will be flushed. So based on this, if I am choosing for 0, 0 it is no operation, nothing but option 1 is correct. Moving on to sixth question. Which of the following is incorrect reference to the array in the case of FORTRAN? So this question is actually out of syllabus. Strictly speaking, FORTRAN is not in the syllabus. So for this, the corresponding option is 2 star 3, nothing but 2 into 3 comma 6, nothing but option 2 is going to follow. Moving on to seventh question, what they have given is the normalized impedance of a transmission line is given by the expression. We know that the normalized impedance, or let me talk about characteristic impedance. So characteristic impedance is given by under root of L divided by C, which is equals to under root of Z short circuit into Z open circuit. This is equals to the characteristic impedance, or one more formula is mod of V max divided by mod I max. So this is the characteristic impedance formula. Now what they are asking is, they are asking normalized impedance. Whenever they are asking about normalized impedance, you have to divide by Z0. So what you will be getting is mod V max divided by mod I max whole divided by Z0, whole divided by Z0. So this is normalized impedance. So the corresponding option that is going to follow is option 4 is correct. Moving on to 8th question, which of the following is associated with single balanced modulator circuit? We know that single modulator or balanced modulator, what you will be doing is, you will be having two inputs. The first one is message signal and the second one is C of t, nothing but the carrier signal. Hence you will be getting a modulated signal. So in the case of double sideband suppressed carrier, nothing but double sideband transmission, we are going to make use of a balanced modulator. Hence the suitable option that is going to follow is option 2 is correct. Moving on to 9th question, what they have given is FM kilocycles per second modulating frequency provides MF equals to 2, that is significant Bessel function, that is N is 4. In the case of FM wave, what bandwidth is required for passing this wave keeping delta f as constant? If frequency modulated signal is doubled, what will be its effect on MF, they are asking. We know that the modulation index beta, which is equals to MF, which is equals to delta f divided by FM. So this is general formula. So let me take this one as case 1. In the case 2, what they are telling is, they are going to call it as MF dash, which is equals to delta f, they are not weighing. So frequency deviation, they are keeping it as constant, but modulating frequency they are varying. They are going to call it as FM dash, which is equals to twice FM. So when the denominator is getting doubled, then MF dash will be divided by 2, nothing but it will be half of the quantity. So MF would reduce to half of its original value. So the corresponding option that is going to follow is option 3 is correct. Moving on to 10th question, the Nyquist plot of a system is given below. So they are asking the type of the system they are asking. In order to find the type of the system, simple thing is, if your graph is starting from here, or if your Nyquist plot is starting from here, then it is type 0. If it is starting from here, it is type 1. If it is starting from here, it is type 2. If it is starting from here, it is type 3. This is order 1. So this is order 2. So this is order 3. And this is order 4. What do you mean by order? So number of poles at the origin determines order of the system. Now the graph is starting from here, nothing but it is a type 1 system. Hence the suitable option that is going to follow is option 2 is correct. 11th question, what they are given is, in a half wave rectifier, the open circuit voltage from the secondary of the transformer is Vs equals to Vm into sine of omega t. Then the peak value of load current will be, where Rf is the dynamic resistance of the diode and Rs is the series resistance of the transformer secondary. Now if I want to calculate the load current, it is voltage divided by the total resistance. It is voltage divided by total resistance. So voltage is source voltage, that is Vs, divided by the total voltage is Rs, nothing but resistance of transformer secondary, plus Rf, nothing but dynamic resistance of the diode, plus the load resistance, which is option 2 is correct, where Vm is the peak voltage. So the corresponding option that is going to follow is option 2 is correct. Moving on to 12th question, what they are given is, read the following statements regarding a typical filter. The characteristic impedance of a filter must be chosen such that the filter may fit into a given line. This statement is correct. Second statement what they are making is, the cutoff frequency of a filter demarcates the pass band and the stop band. Yes, this statement is also correct. Let me think about low pass filter. So the characteristic curve will be something like this. But if I am speaking ideally, the characteristic curve will be something like this. So this will be my pass band and this will be my stop band. This is cutoff frequency, that is FC. So FC is making a demarcation between pass band and a stop band. So statement B is correct. What statement C they are telling is, a typical filter must be having very much high attenuation in the case of pass band. You should not be having any attenuation. That is what we require. But what they are telling is high attenuation. So this statement is false. What statement D they are telling is, a typical filter must have very much low attenuation in the case of pass band. This statement is also a wrong statement. If they are reversing the statement C and statement D, then C and D would have been correct. So statement A and B is correct, nothing but option 1 is going to follow. Moving on to 13th question, the voltage gain of a bipolar junction transistor in the case of common emitter configuration is. We know that in the case of common emitter configuration, you will be getting a negative sign. This negative sign indicates that output will be having a phase variation with respect to input. Nothing but output voltage or current will be having a phase variation of 180 degree with respect to input voltage or current. So this negative sign indicates it is 180 degree phase variation, which is equals to minus of HFE divided by HIE times of RL. So A is correct and B is wrong. So I can opt for option 1. Moving on to 14th question, they have given the binary data and you have to convert into a gray code. So in order to convert a binary data to a gray code, which gate is required and how many gates are required, they are asking. We know that the given data is 11, 00, 11. So in order to convert the given binary data to a gray code, what is the standard procedure is, first bit you are going to retain as it is. So it is 1. What is 1 XOR with 1? It is 0. What is 1 XOR with 0? It is 1. What is 0 XOR with 0? It is 0. What is 0 XOR with 1? It is 1. What is 1 XOR with 1? It is 0. So which gate you are using? You are using XOR gate. How many XOR operations you have done? You have done 5 XOR operation. So you are in need of 5 XOR gates. So statement C and D is correct, nothing but option 3 is going to follow. In the case of gray to binary, what you are going to do is, from output to input you are going to make use of an XOR operation. So the standard procedure of finding binary to gray code and gray code to binary code you should know. Moving on to 15th question, what they are given is, in the case of microprocessor 8086, it is a 16-bit processor with 16-bit internal and external bus. This statement is correct. The data bus is of 16-bit wide. The address bus as well as control bus is of 20-bit wide. The instruction queue length is of 4 bytes they are telling. It should be 6 byte. And queue operates in first out fashion. While entering alt mode, in the case of minimum mode, address latch enable is delayed. Now, this address latch enable is used to multiplex the data bus as well as address bus. The control pin in the case of 8086 is M/IO. Yes, if M/IO equals to 0, then you are going to make use as an IO. If it is 1, then you are going to make use as a memory. So A and D statements are correct, nothing but option 3 is going to follow. Moving on to 16th question, what they are given is, they have performed an operation A equals to A star B plus A or A into B plus A. It can also be written as, this one if I am writing, it is A equals to A star of B plus 1, which is equals to A into B plus A. So statement A is correct. What about statement B? It is wrong statement. What about statement C? Even this statement is also correct. If I am multiplying inside, what I will be getting is A into B plus A, which is equals to A. So A and C is correct. What about D? If I am performing this one, I will be getting A equals to A star B plus A star A. So D is wrong. A and C statements are correct, nothing but option 4 is going to follow. Moving on to 17th question, a lossless line has a characteristic impedance of 50 ohms. It is terminated in a load resistance of 75 ohms. The line is energized by a generator which has an output impedance of 50 ohms and an output voltage of 30 volt RMS. The line is assumed to be 2.25 wavelength long. The input impedance and instantaneous load voltage are given by. We know that whenever they are talking about lossless line, you can talk about the conductivity which is equals to 0 and alpha equals to 0. So what they are given is the characteristic impedance which is equals to 50 ohm. The characteristic impedance which is equals to 50 ohms and the line is terminated by a load impedance of 75 ohms. So ZL equals to 75 ohms. Now what they are given is Zg. On the generator end, the impedance is terminated by 50 ohms which is equals to the characteristic impedance, that is Z0. Generator voltage which is equals to 30 volt RMS they are telling. So we need to calculate what is the input voltage and we need to calculate what is the load voltage. If I am calculating theta which is equals to beta L, where beta equals to 2 pi divided by lambda, and what is L? L equals to lambda by 4. L equals to lambda by 4. So what you will be getting is pi by 2, right? And one more thing, what do you know is Zin. How can I define? Which is equals to Z0 square divided by ZL. What is Z0 square? Which is equals to 50 square, which is 50 into 50 whole divided by what is the value of ZL? ZL they have given it as 75. 25 2 times, 25 3 times. So it is 100 divided by 3. So I will be getting Zin which is equals to 33.33 ohms. Zin equals to 33.33 ohms. C is correct. Now we have to calculate what is the load voltage. The generator voltage what they have specified is 30 volts and the characteristic impedance is 50 ohms. It is terminated by a load impedance. It is terminated by a load impedance. The load impedance value is 75 ohms. So the characteristic impedance is 50 ohms and the load impedance is 75 ohms. So you will be getting a reflection over here. So in order to minimize this reflection, what you have to do is you have to keep the length very much long, or you have to go for single stub matching or double stub matching. So what is the impedance, that is Zg? Zg is also equals to 50 ohms. Zg equals to 50 ohms and line impedance is also 50 ohms. So you will not be getting any reflection. So source is safe. Now let me apply voltage divider rule in order to calculate the value of VL. So in order to calculate the value of VL, so how can I express VL? VL equals to Vg into 75 divided by the total resistance is 50 plus 75. 50 plus 75, where Vg is 30 volt RMS. So what I will be getting is VL equals to 12 volts. The corresponding statements that is true is C and D. So option 3 is going to follow. 18th question, which of the following statements are incorrect? First statement what they have given is, in a frequency modulated system, the frequency of the carrier wave is varied in accordance to the frequency of the modulated signal. So this statement is correct, but they are asking for incorrect statement. So A is wrong. In statement 2, what they are telling is, in the case of pulse amplitude modulation, there is a greater peak power compared to the conventional amplitude modulation system. Even this statement is also correct. Since they are asking for incorrect, this statement will be a false one. What statement C they are telling is, in the case of pulse code modulation, the sampled amplitude is directly taken for conversion to a code of pulses. This statement is an incorrect. First step is, you are going to take a sample, then you are going to quantize, then you are going to encode. So quantizing you are going to do. And if you are preparing for gate exams, droop rate you should know. What statement D they are telling is, the noise in the pulse code modulation system is reduced by increasing the number of quantization level. Even this statement is also wrong statement. Noise in the case of PCM, if you are increasing the number of quantization level, the noise reduces. So in the case of sinusoidal, the signal to noise ratio is given by 1.76 plus 6n in dB. So the corresponding statements that is incorrect are C and D, nothing but option 2 is going to follow. 19th question, which of the following statements are correct? ASK will be having a maximum probability of error. If I am talking about ASK, FSK, PSK, ASK will be having maximum probability of error. It is a true statement. Hence, in most of the cases, we will not be using ASK. FSK is also known as on-off keying. This is false. FSK is not called as on-off keying. ASK is called as on-off keying. In the case of DPSK, you don't require synchronization. Yes, you don't require synchronization. So, circuit complexity is less. Probability of error in the case of DPSK is less than BPSK. This is also a true statement. The corresponding option that is going to follow is option 1 is correct. In the case of ASK, the probability of error in the case of ASK, it is given by half times of erg function under root of EB divided by 4n0. EB divided by 4n0. Probability of error in the case of FSK, it is half erg of under root of EB divided by 2n0. If I am talking about probability of error in the case of PSK, it is given by half erg of under root of EB divided by n0. So you should remember the probability of error in the case of ASK, FSK, PSK. The probability of error in the case of DPSK, it is given by exponent of. It is expressed in terms of exponent. So this is one thing what you have to remember. Why we are not going to prefer ASK means the major drawback is the probability of error is more. But in the case of FSK, bandwidth ideally required is infinite. So you are not going to prefer ASK and FSK. The best technique is PSK. Now if I am talking about constellation diagram in the case of ASK, one point will be over here and another point will be over here. So this is the constellation diagram in the case of ASK. But if I am talking about FSK, the constellation diagram you will be getting something like this. One point will be over here and another will be over here. If I am talking about PSK, one point will be over here and another point will be over here. So this is the constellation diagram of ASK, FSK, PSK. You should remember the constellation diagram of ASK, FSK, PSK and how you will be getting that constellation diagram. If the points are near, what is the impact on probability of error also you should know. Moving on to 20th question, what they are given is, read the following rules to sketch root loci. The root locus always start from pole, this statement is correct, and terminates at 0. If I am talking about inverse root locus, it will be starting at 0 and it will be terminating at pole. In the case of root locus, you will be varying only one parameter, that is most of the cases you will be varying gain. But in the case of root counter, you are going to vary multiple parameters. Keeping all of the parameters as constant, you are going to vary a single parameter and then you are going to solve. It is similar to superposition theorem. So, statement A and C is correct, nothing but option 3 is going to follow. 21st question, match the following: junction depth, junction built-in voltage, charge neutrality condition, laws of mass action. We know that mass action law, which is given by NP equals to Ni square. Again, I am going to tell mass action law NP equals to Ni square. If I am talking about junction depth is under root of 2 epsilon Si phi naught divided by Qna. If I am talking about junction built-in voltage, it is given by KT divided by Q into ln of NA/ND divided by Ni square, where KT divided by Q is thermal voltage. I can write it as Vt. And NA/ND, we know that it is concentration. Intrinsic carrier concentration, it is represented by Ni. Charge neutrality condition, it is Na times of x1, which is equals to Nd times of x2, where x1 and x2 are the junction depth along N side and P side. So based on this, if I am choosing, I will be getting option 4 as correct. 22nd question, again you have to do for match the following. 1. What is the transform? It is 2 pi into delta of omega. U of t equals to 1 divided by j omega plus pi into del of omega. For delta of t it is 1. For mod t, it is minus 2 divided by omega square. So based on this, if I am choosing, I will be getting option 1 as correct. Moving on to 23rd question. On the list 1, they have given inventor name. On the list 2, they are talking about what they have invented. William Schottky. So William Schottky, what he has invented is, he has invented BJT. He has invented BJT. Now if I am talking about Kilby, it is integrated circuits. You are very much familiar with respect to JK flip-flop. It is Jack and Kilby. So they have given their name only. So next one is Isaki. Isaki has invented tunnel diode. Linenfeld, it is MOSFET. So the corresponding option that is going to follow is option 2 is correct. Moving on to 24th question, match the following. On the list 1, they are talking about IC number. On the list 2, they are talking about gate. 7400, it is quad 2 input NAND gate. 7402 is quad 2 input NOR gate. 7408 is quad 2 input AND gate. 7432 is quad 2 input OR gate. So the option that is going to follow is option 2 is correct. Last question. Till now, if you have not liked the video, please give it a big thumbs up. 25th question. So on the list 1, they are talking about port or control register. On the list 2, they are talking about address. So when it is 00, when it is 01, when it is 10, when it is 11. So when it is 00, port A will be activated, or you are going to point to port A. When it is 01, it is port B. When it is 10, it is port C. When it is 11, it is control register. Control register. You are going to point to control register. So the corresponding option that is going to follow is option 2 is correct. So in this video, I have discussed question number 1 to question number 25. In the next part of my video, I am going to discuss question number 26 to question number 50. If you have followed the solutions what I have provided, please give it a big thumbs up. Also share this video with your friends and don't forget to subscribe to my channel Craving Gyan. All the best for exams. Thank you.